Welcome everybody back to the nest. I'd like to shout out to everyone who has subscribed in the last 8 months and watched our videos. We have reached the point where we are now being monetized by YouTube. It's a great day for us. We are jazzed about putting out content every week. We're trying to share what we're doing on the floor, and we're really pleased with the feedback that we've been getting from everyone, and how much you enjoy the videos, and how much discussion it's caused. Thanks for watching, and hopefully we can keep going and build this community. I'd like to invite anyone who's new to the channel, or even if you haven't, if you've been around a while and you just keep seeing our episodes, to go over to our website and have a look at the tab on the side that allows you to see a free plans sample. You may be interested in a koala, or you may be interested in an Avenger or a tiger moth. We have a little snippet of the plans. It's not the whole plan, but if you don't know what the plans look like, it's kind of nice to be able to pick that out and then say, okay, well, I get how they're trying to communicate the information to build the airplane. And we've taken a little snippet from every different aircraft that we make, and so you can choose which one you want. And so if you like the koala, or you like the Dakota Hawk, or you like a classic, you can pick a little snippet of the plans from that model and have a look at it, and then make your decision on whether you want to pursue it further. So over the next 2 weeks, all the people who take free plan samples, we're going to gather all the names, and we're going to make a draw. And so at the end of the next 2 weeks, about March 1st or so, when that next video comes out, we'll make an announcement as to who is winning a free mug from us. So when you pick the plans, you give us your contact information. So we'll be in contact with you and tell you that you won. So go to the website, pick out which aircraft you like, and take a free plan sample and see what it's all about. Today I'm going to share our conclusions from the wood species testing analysis. Now, this may be a little bit dry for some people, but I've had a lot of interest in people who are looking to find a replacement wood for Sitka spruce, which is very difficult. It's almost unobtainium now to get it, and the price is astronomical. So we've gone through the process with a proper engineer, and we've done the load analysis, and I'm going to go through that a little bit today and share our results with you, and I think you'll be surprised. To round out this video today, we are going to share with you the 4th installment of the youngster tail kit build with Algy Yates. This week he demonstrates how to properly install gussets, and he answers all of the questions that I usually get about the gusseting process. Here we go. Enjoy. This is Fisher Flying Products. I'm Dave Hartner. Welcome to the Nest. Our video newsletters provide weekly insight into building and flying our 15 wooden aircraft designs. Plini Motori of Italy is a gracious sponsor of our channel. Plini is the manufacturer of the Thor 250 DS. Cozy Carb Ice Prevention Systems is a proud sponsor of this channel as well. Please take the time to watch our videos to the end, as this assists us in the metrics that YouTube uses to rate our channel. Hit the like button if you feel that the content is worthy. We invite you to subscribe to our channel by clicking on the subscribe button and hitting the bell so that you are notified whenever we post our newsletters. In the past videos, I have taken the opportunity to do some testing for the substitution of northern white pine for the Sitka spruce in our designs, and I just wanted to go through this very quickly with you and show you the seriousness of our work. We did go in and worked with an engineer, and we put all of the different various woods in a graph form that showed all of their relative parameters. And then from there, we did the math. We put all of the information from Sitka spruce and northern white pine with respect to bending strength at proportional limit and modulus of rupture, and put it through the math. And we came out with some numbers. And then from there, we had to institute those numbers into the front spar calculation. And we went through the front spar calculation and came out with a result in yellow here that we are within 0.78% of strength in the situation where it's being used. You have to know the situation where it's being used. You can't just make a blanket statement. And so therefore we're within 1% there, and then we're within 0.5% on the rear spar. And this is for the 202 calculation that we're doing, these actual numbers. And from there, we go down and we put the numbers in for design allowables, and we find that we're well within the safety factor and the safety limits of only reducing the strength by less than 1% on both the front and rear spar. So we're going ahead with the substitution of northern white pine for the Sitka spruce in our designs. So now I'm going to hand it over to Algy Yates for his 4th installment, and you're going to learn how to do gussets today.
In this video I'm going to go through fitting the gussets to the horizontal stabilizer. There's 2 ways of doing it. You could chamfer the 16th ply, sand the joints and glue them directly on top of the framework that you've already created. But that shows through the covering, and to me it doesn't look particularly professional. The alternative, which is accepted by Fisher, is to inset the gussets onto the joints into the tailplane so it's a flush fit. And when I actually thought about it, the time taken cleaning up the joints and chamfering the edge of the gussets is pretty much the same as it would take for me to do this joint. So join me in the video and see how I do it. Right, so I've only got an old and rather cheap table saw that's seen quite a lot of service. So I've clamped down a piece of wood down here so that my plywood can't slip underneath, because it's only 16, so it can't slip in underneath there. I've only set the blade a fairly shallow height, and the reason for that is if I have it higher it's going to try and cut and split the thin ply. It's much better for it to be cutting it at a shallower angle. I've set the gap from here to the edge of the blade of just over 2.5 inches. As the strip is 5 inches wide of ply that's supplied for the tailplane, that'll give me one piece that's just over 2.5, which is what I need for the spar and leading edge block area, top and bottom. And the remainder of the strip will be just over 2.25 inches, which is what I need for all the other gussets. So I'll trim the sheets and then we'll get on and do the rest of the gusset making. And if you're wondering why I didn't use a push stick, it won't grip it, so to push it through. So one piece 2.5, I should think. Check. Yep, 2.5, and one piece just over 2.25. So cutting the gussets, the only thing I do is I mark it up. I use a steel rule, Stanley knife, take it easy to get the initial scalls in so that the knife tracks, and of course you've got to be careful that you don't chop your fingers off. I've got the end of the wood there just clamped. Now I've got a groove, a bit more pressure, and that should just go like that, and that'll just take a light sand, and there is one 16th inch gusset ready to go. Okay then, so I want to set the height of my router to be able to route down the thickness of the plywood gussets. So I've got a surface plate here. I'm putting a couple of sheets of paper down. That's to make an allowance for the thickness of glue, always make room for the glue. I'll put down plywood of the thickness which I'm going to be routing. To accept, I put my routing jig on. This allows me to be able to route straight edges against datum lines on the wood, and to keep the whole thing nice and level. I can now put my router on. I can push this down until the router bit just touches the surface plate. I can lock it. I can set the adjustment height bit there. Now this is set so that it'll cut the thickness of the plywood and plus the thickness of the paper, which should allow us to have enough room for glue. So here's the setup in position. This will be run across. Rotation of cut of the cutter is this way, so you always want to be driving it in this direction. That way it'll save things splintering out. So here we go. I've done it slightly differently to the plan. The plan shows, if you look there, you can sort of see that it's sort of cut as a square, but because the laminations run at 90 degrees to each other, I wanted to go as a diagonal. We've got more going across the joint, so a slight deviation. So this will fit in there just perfectly. There we go. Just the right depth. No step. We'll just route out this down to depth. So I'm going to do the side here. Then I'll do that side using the guide edges. I'll turn this around and then I'll be able to cut the remainder back that way. So safety glasses, #1 priority. Remove the jig. Just give that a little sand just to get any slight steps out. And hopefully that piece should sit in level all the way, ready to be glued like that, and the excess will come off. You'll see that later. So I'm going to do this to all the rest of the pieces. So as you can see here, I'm bonding in the gussets. I'm using a piece of thin scrap plexiglass that I had, but I could use a piece of plywood with a plastic sheet between, and I'm just weighing down. It's bridging the gap, so the weight is actually mainly on the framework, less on the plywood gusset. The idea is it'll settle itself nice and flat with the stiffness of the plexiglass, and you'll get a small amount of squeeze out running out onto the wood either side, which will be easily sanded. As you've seen, the gussets are cut oversized, so there's a section there that's going to have to come off, and that I'll do with a edging bit on the router, which you'll see later. Well, let's have a look and see what we've got then. Let's take this off. That came off nice and easily. Yeah, we've got sort of a shine. It feels remarkably level with a little bit of a sand. Let's just have a try. And then that's all it takes to get rid of the excess off there. So I'll carry on and crack on through all the rest. But yeah, that all feels reasonably level. I'll sand this lot off and then I will go around with an edge router and show you what the product looks like then, and then it'll be over to the other side. Here we are. All the gussets on this side have been routed, edge routed, to get them to conform to the shape of the frame underneath. So they're all ready to go. All the glue has been sanded. You can still see the staining of where it's gone out, but everything is flush there, so it's nice smooth transitions everywhere. Not that difficult really, and so all we're going to do now is do the other side. So here we go, the other side. This is the other side, all done. I've done the edging with the router. I'm just sanding down at the moment with 80 grit. So I'm happy with that. Then I've got 240 grit on this side. So again, nice smooth bit, and then I'm just going to go over the rib like that, and then just to get rid of the sort of little edges and bits, to flatten out any lumps, just a 220 grit. Around the edge there. Horizontal stabilizer nearly complete. Now you've seen I've routed and I've been sanding. I've been sanding using a block, 80 grit on one side, 240 on the other. The importance of using a block I can't overemphasize with this. You want to have nice flat joints, and the main wood used in the construction, the spruce, is softer than the ply, so use a block. Talking about ply, Fisher supplies 2 pieces of 5-inch wide 16th ply for the tailplane assembly and 2 6-inch wide 16th ply for the fin and rudder. Now with my saw I can produce 4 2.5-inch wide, or nearly 2.5-inch wide strips to do the centre section of the rear spar of the horizontal stabilizer, all the joiner on the elevator, so 4 pieces needed for that. So I will be raiding the 6-inch wide ply for the fin and rudder. I've done the calculations, I've worked it out and I've mapped it out on the plywood, so I can still have the pieces for doing the rudder closure and produce all the gussets required. So a bit of planning needed, but there is enough plywood there. If you had a bandsaw, you could nest these together, in which case you might end up with some nice spare plywood at the end. So time to this point, with it all sanded, so taking into account what we've done, total time 10.1 hours. The time it took to do the gussets, so the cutting of the gussets, routing the recesses for them, routing and sanding afterwards, 3.3 hours, so not a huge amount of time. In the next video I will be doing the leading edge, showing you how I round the leading edge, finishing off the tips of the bow to get the horizontal stabilizer to the point where if we had metal hardware we could then continue, and I will then go on to creating the trailing edge bows for the elevators using a slightly different laminating technique because of the tighter radius. It's one which I've used on boats in the past, which has allowed me to do a tighter radius than you might normally do without soaking the wood. So hopefully that will work. We'll find out in the next video. Bye now.
Thanks again for watching. We try hard to bring you interesting content each week. To help us out, please like and share our videos if you feel the content is worthy. To receive the latest info from Fisher Flying Products, click the subscribe button and ring the bell. See you next time in the nest.